get started. This is the second part of my second stream, and I'm going to try to continue with the work that I started a couple of days ago on the Walrus operator in PyPy. I didn't do any work in the meantime, though I did read a little bit on how on some of the corner cases of the Walrus operator that I didn't really understand last time. Okay, so let's see. Let's actually look what I did the last time to remind myself a little bit. Right. So we did a couple of steps. At first, I changed the tokenizer to actually recognize the new token, the new : token, and then I ported over some of the changes in the CPython 3.8 grammar to PyPy's 3.7 based grammar, which is basically a new production and a change in the rule for argument passing. And then I started adding the bytecode generation, which is actually pretty simple. It's a dub which duplicates the top element of the stack, and then it does a store to the variable. And then we entered a part that I wasn't really aware of before, but I was rescued by isIdentical on the chat, which is that there are a couple of interesting interactions of list comprehensions and the Walrus operator, and I kind of forgot of. I mean, I think at the time when the operator was discussed, I kind of read some of the discussions, but I forgot all about it in the meantime. So I had to rediscover it. Thankfully, isIdentical helped me out, and we got started at implementing them. And just a small hint of the problem, which is that if you have a function and it has a list comprehension with a Walrus operator in it, then this actually has some interesting questions. I mean, the first interesting question is that this list comprehension nowadays really is executed in a subscope. It has its own code object, and that means there is no automatic sharing between the variables that occur in here and the outer scope. And before the introduction of the Walrus operator, it was only the iteration variables anyway. So there wasn't really a deep problem. It was actually an intentional decision to not leak those iteration variables to the outer scope, which was made in one of the 3.x releases. But now with the named expressions, it's kind of a wanted property that we want the name that is assigned in here to leak, and we want that to be visible in the outer scope. So if we run that, we will get the last value of y, which is 9 times 545. And if we look at the disassembly, yeah, it looks like this. So this is the outer function f, and this is what happens in the list comprehension. And as we can see, it really in the list comprehension, it really uses store deref, which means that it's an up value. It stores the value of y into a cell, and the cell can be read up here by saying load deref. Okay, and that's the part that I didn't really understand before last week, and understand somewhat better now. So, and that's also the part that we kind of got done near the end of the last stream, but there's still a couple of cases that aren't finished, and I'm going to start working on those. Right. Okay, so let's see, where are we here? Let's start running some of the tests that we wrote last week, just to check that they still work. Right. Did I not call them? Wait. let's look. Yeah, let's see. Oops, am I on the right branch? Yes. Maybe I'm in the wrong file. Ah, yes, there are two test compilers, of course. There's one in interpreter/test/compiler, and then there's one in AST compiler/test/test compiler. And we want that one. And as we already noticed last week, running tests is a little bit slow if you have to wait for it on the stream. I never really notice it that strongly if I develop on my own, but then if I basically need to fill the void with talking, it becomes a little bit more stressful. Right. Okay. Somewhat unsurprisingly, they still pass, and they're here. Right. The first test is really very simple. It just assigns something, and then the second test we check that that the assignment expression actually evaluates to the right-hand side of the expression, and then we immediately went into one of the more complicated cases around assignment expressions and comprehensions. And so there are a couple of things that we need to continue with. One of the ones that we need to continue with is more cases around the interaction of comprehensions and the assignment expression. But there's actually another thing that we really need to do, and that's we need to. There was a second production in the grammar that we added. I'm going to open the grammar again. PyParser data grammar 3.7. And the one new production that we added was the named expression test here, which is a new kind of expression, and we handled that properly. But there was another case where we added something to the grammar for the Walters operator, and that's the argument parsing of functions. And basically that allows us to call a function and have one of the arguments be an assignment expression. And we didn't actually change the AST builder for that case at all yet. So actually that case is the one that I want to start with now before we dive further into the details of list comprehensions and the Walters operator. And for that, I'm going to start writing a test again. And I mean, we can look at an example first here. Basically, it allows us to do something like this. We pass it as an argument to a function call, and afterwards x has the value of the empty list. And I think that actually doesn't work yet. So let's try. If we say len x equal like this, then x should evaluate to the empty list. Okay, let's try that. And we didn't touch the AST builder for that case at all yet, so I kind of expect that it is broken. Right, and it's broken in somewhat weird ways. It gives this error, global name x is not defined, which means that it doesn't, I mean, the compiler really doesn't do the right thing here yet. It somehow tries to read the name x instead of recognizing that it's a new kind of assignment. Okay, so that means we need to go to the AST builder and look at where we handle function calls. Right, funcdef is not correct. More funcdefs. Handle arguments, that's promising. No, that's maybe the arguments in a function definition, so maybe not the right one. Call handle trailer. That's maybe better. Let's see. Handle call. Okay, there's simply a handle call, and we can look at what it does. So that's the code that builds the AST out of the concrete syntax tree for function calls, and in particular looks at the arguments of the function calls and produces a proper object for that. And what it does here is it goes through the arguments in the concrete syntax tree, and it checks for the number of arguments of the concrete syntax tree in this production here. And it distinguishes these cases based on the number of children the nodes have. And basically it mixes up, I think, these two cases, because of those two cases, both the concrete syntax tree nodes have 3 children, the expression, the equal, and the other expression in one case, and the expression, the colon equal, and the other expression in the other case. And I suspect that those two cases are mixed up by the AST builder and not distinguished properly. And so if we go here, we can look at the if statements that occur here, and I think that's indeed what is happening, maybe. At least that's what I was expecting. A bit confused. I think it's here. Basically here it says if the number of children is 1, we have a positional arguments, and this condition needs to become somewhat more complicated, because in the case of a named expression, a Wallis operator, we also have a positional argument. It's not a keyword argument. So we have a positional argument that, as a side effect of passing the value into the function, will also assign a name to the value. So this condition needs to be made more complicated. And let's actually check that theory. So we can say something like if x in wrapper argument PDB. And then we can debug our case. It's possible that there are a lot of other, that this is triggering too often and we need to rename x to something a little bit rarer, but we'll see. Right, okay, it didn't trigger, that's a pity. Let's always put a PDB there. Oops. Why is this not doing anything? It's not triggering at all. That's even more confusing. Why is that? Am I in the right place? I suspect I'm somehow not completely in the right place. Or was I? It looks right. Okay, I'll try again and try to figure out why this is going wrong. PDB. I'm really confused. Am I doing something really stupid, like editing the wrong file or something? Let me try that. No. little bit lost again. Let's see whether the whole function is ever reached. No. Ah, ha, 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 ha. Okay, I'm doing something impressively stupid, which is that I didn't quote the x here. So it's trying to look up the x in the test function, and of course there is no x here. So the error doesn't come from PyPy's compiler at all. It comes from the CPython compiler that's trying to run this function. Okay, that explains at least why I was having difficulties. And we can go back to trying this approach. Oh wait, I didn't save here. Maybe now the world makes some more sense. That's a problem that doesn't happen that often, but it happens occasionally that I'm becoming very confused by the two levels. I mean, there are two levels of Python code involved. There's, on the one hand, there's the underlying Python that's running the Python interpreter, and then there's the upper Python. And it's not that rare for me to, I mean, it happens occasionally that I'm confused by the two. And now I was getting an error that I was expecting to come from the upper level, but it was really coming from the lower level. And now I think our if is a bit too eager because we didn't even start running our test yet. It triggers too often. So we need to be a little bit more clever and rename the variable here to something that doesn't occur in some of the startup code that the bytecode compiler needs to start first. It triggers on something called exception type. So let's try to be more precise and rerun. Okay. Yes, very realistic. It took me 20 minutes to even get started with anything. Let's hope it works now. Oops. Right, yes, that looks good. Okay, so what's the argument? The argument is this scary looking concrete syntax tree node, and we have a foobar, and we have a terminal : equal, and then we have a list, square opening bracket and square closing bracket. So we're in the right spot, that's great. And now we need to see what the current code does with that in that case. It skips the first, right, I can do this. It skips the first case, which is a positional argument, which is really where we would like to end up. So the fact that we skip that is bad. Right, and then we end up in a case that's called a keyword argument. So it thinks that we're dealing with a keyword argument, which is of course wrong. That means my intuition that we need to do something better about this case is correct. So if we continue now, then it should explode in some way, and it explodes in the way saying len got an unexpected keyword argument foobar, and that indeed shows the problem. The problem is that it thinks this looks like this because it doesn't even look at the second symbol here. It just says, oh, there are three symbols, so we must be in the case of a keyword argument, and that yeah, that's wrong. Okay, so what we need to do is we need to fix the first condition to not just check on the number of arguments here. Instead, we need to make the condition more complicated. We need to say or argument.numChildren equal 3 and argument.getChild1 dot type equal, is it type? I think it's type. Equal tokens dot name, no, colon equal. So what we're saying here is that we have a positional argument in one of two cases, either if it's really just a single syntax tree, or if it has 3 children and the second children is a colon equal. So now the condition is correct, but now we need to do something a little bit more complicated to deal with the named expression. We need to create the named expression here. So here we need another if. We need to do the checks about positional arguments not being allowed to follow keyword arguments, blah, blah, blah. But then down here, when we actually append the argument to the list here, we need to say if argument.numChildren equal 1, then it's simple. Then we take this code and else the argument is something. And I think the something is a new method that I'm planning to write that creates a named expression AST node, and which is then passed in here. And the way that looks is we're taking the lines here that we wrote a couple of days ago in handle expression. We take them and we put those into their own method and call that from both places. So here we say return self.handle named exper of expression node, and this goes into a new method here. Oops. Self expression node, and that does the right thing for named expressions, and it does the correct thing here as well. No, maybe not. We're passing the wrong thing. Expression node is the first child of the arguments, but we need to pass the whole argument thing because that's the concrete syntax tree node that has the 3 children. Hello. Unfortunately, I still didn't manage to debug my Vim configuration. There's still a plugin that occasionally will freeze stuff under conditions that I haven't understood yet. And it's sort of just not annoying enough for me to actually spend the half hour to fix it. Right. Okay, that has a decent chance of working. Did I still leave the PDB in? Yes, I did. It's okay, then we can look at it working. La la la. Code looks good. Let's see what the test thinks once it decides to actually do something. Right. Okay. We're at the PDB, so now we hope that the first if expression will actually trigger. So let's try. It does, great. And we're not in the error case, and we're not in the simple case. Instead, we're in the handle named expression case. and the rest of the stuff should just work. The target expression is a name, and the right-hand side is a list, and then we make a named expression with the right position information, and that should work. It does, great. So let's kill the PDB. The other tests kept passing. Let's look at the diff. Right, we factored out the named expression creation into its own helper method, and we called that helper method in the other grammar production that we changed, which is argument passing to some function. Okay, good. And there's a test, of course, at the bottom. Fantastic. Let's commit that. That's the PyPy internal syntax for having more than one person work on a commit. Support passing named expressions as function arguments. Great. Okay, that's a good step forward. And now we have no excuse left but to go back to the mess that we started at working on last week, which is the interaction of list comprehensions and the Walrus operator. And the code that we wrote for that was in symtable, and we have a visit named expression here. And what that does is it does complicated things. That is a file that figures out in which scope every variable reference in the Python code should go, whether it's a local variable or an up variable, something that's closed over, or a global variable or a class variable, or various other cases. When we find a named expression, we will go up the parent scopes and check whether one of the if we have a named expression in a list comprehension, we do that. And then we go up the scopes and we make sure that the name of the that is assigned by the named expression ends up being in the right enclosing scope. And there were a couple of cases that we didn't handle. We didn't handle list comprehensions on the module scope level, and we didn't handle the list comprehension in the class scope level, and we wrote some code here that we didn't write a test for. And so we need basically 3 further tests. We need a test for, we have a function scope, but the variable that we assign in the list comprehension named expression is a global already. We only handle the other case, that it's not a global. And then we need to make this work on a module scope and in the class scope. So let's start with the global one, and that's basically a variant of the test that we wrote last week. And it looks basically this, like the code that we wrote, and we just need to make sure that the variable is in the global scope when we find the list comprehension already. Right. It's happening again. Right. No, we can go immediately here. Right. This is the code, and we want to make a copy of that, and we want to, in the copy at the beginning of the function that we're calling, we want to say global y, then y ends up to be on the global scope, and that means after the function call we should be able to look up the global name y, and then the result should be 8. Let's try that. That should just work because that case we already implemented last week. So last week we already wrote this condition here, and we said that okay, if the name in the function is already global, then the named expression should also assign to that global. The cases that we didn't implement yet is let's write that immediately. That's actually a rather simple case. We do the same thing. We have a list comprehension on the global scope, and then of course the assignment should happen to the global scope. So we should be able to look up y after after we executed the list comprehension with the named expression. And so we expect this case to already pass. Let's actually add some white space to make this slightly easier to read. We expect this case to already pass and this case to not pass yet, because this case should make us run into this unimplemented if statement here. One of the parents is a module scope, and yeah, we will explode on this x-axis here. Right, okay, the first of the added tests passed, of course, and now we need to wait another, wow, it's 50 seconds, really? That's a lot. We need to wait for another 50 seconds. And while we do that, we can think about understanding the third case that is missing here, which is the class scope. And to understand how that should work, let's actually look what CPython is doing. So if you have a class, and in the class body, we have a list comprehension with an assignment expression in there. What do we get? And something that I really didn't know is that would be CPython actually decided to make that illegal. So we get a syntax error, and because assignment expressions within a comprehension in a class body are simply forbidden. Right. So how's our test doing? Still running. Right. And it crashes where we expect it to crash, on the unimplemented second case. Right. So the second case is easy. It looks very similar to a subset of the first case. We say parent.node symbol name sim global and scope.node symbol name sim global. So in both cases, I mean, it's a module scope anyway, so all of the names are global, and that simply means we need to make sure that the name remains global in both of the scopes. Right. And then the second test should pass. While we wait for that, we can write a test for the new case, which is the error case. And I need to remember how you write error tests in this file. Okay, this is running good. So we need to say, I think it's something like error test, right? We can say yield self dot error test and class A be consistent with the other examples we wrote for y in range 5, and we expect a syntax error, and we need a closing parenthesis, and we're not getting that yet. We should be hitting this x-axis here, and we can, while we wait for that to happen, we can look at, right, this is not the built-in syntax error. It's a little bit of a bad design here, that we overwrite the built-in name syntax error with our own class. Error. On Twitter, somebody asked me why I'm not using some fuzzy finding file opening thing, and this is the reason. It tends to give me the wrong file or be slow or something. Right, this is our syntax error class. It takes a message, a line no, an offset, some text, file name, last line no, stuff like that. But we only need to set the first 3 arguments. We need to give it a message, a line number, and an offset. And then the missing attributes will be added by some other level of the machinery. Hi Julian, nice to see you again. Right, what Where were we? We were here. So here we need to raise a syntax error with a message. The message we're going to steal from CPython. And for the position, we're going to use the position of the node. So it's node.lino and node.offset, I think. Let's check. No, it's call offset, of course. Yes, it's not nicely consistent as one would hope. It looks like this. Yes, thanks, Palos. As you can already see, I'm not really, I don't spend a lot of time improving my my editing environment. Right. Let's see. I hope this works. I think it should, but you never know. There are actually a few other error cases that we didn't really do properly yet, and maybe another error case is a good next test. So right, those all work. Let's actually commit first. Right. Yeah, so PyPy likes very fine-grained commits, and it's also, as long as you're on a branch, it's also fine to check in sort of half-broken or intermediate steps or known buggy states. And the reason for that is that over the project history, it has sort of emerged that it's often quite useful in the future, like long after the commit has been done, to really understand all the messy steps that the person who implemented a feature took to figure out why something is broken. So we also don't rewrite history. We keep all these things around, and it's really one of the bits of the PyPy development philosophy that we really want to see the messiness, because yeah, as I said, often it's really useful later to figure out what a person was thinking that wrote this weird code that we now have to debug. So implement more cases for list comprehensions and expressions. Right. Okay. So the other thing I wanted to do, as I just said, is I want to add another error case, and the error case is simply that you cannot use assignment expression for complex left-hand sides. So if you have a list, you cannot say, wait, that wouldn't work anyway, L1, L0 colon equal 5. That's not allowed. You can only use a named expression with a name as the target. So a subscript isn't allowed, and nor is any complicated. I think this is also not allowed, right? That doesn't work because it looks like a tuple. But even if we say this 5, right? So it really only works with a name. So that's also a case that we should catch. And CPython appears to be using some advanced code to give nice error messages. So it says cannot use name design with a subscript and tuple. But I might actually cheat a little bit and not implement that completely, and we just say that it should that it expects a name or something. So this maybe belongs a little bit further up. So let's see, yield self.error test. 5, and we expect a syntax error, and I think we are not getting one right now. We're oops, that's wrong. What we're getting now is we're getting yeah, it might even just work. I don't quite know, but we want to prevent it from working, and we do that by going to a handle named expression here, and we check that the target expression is actually a name. So if not isInstance target expression ast.name, then we raise a syntax error, and I'm not really sure whether it's the same kind of syntax error. It is. So we say something like, what does CPython say? Cannot right. This is a slightly worse message than CPython, and right. Interesting. So it already crashes. We already, in the AST compiler, we already baked in the assumption that the target would be a name. Here in the symtable code, but the AST builder will still build that. It actually built an AST with a subscript as the target, and that's the case that we're now forbidding. Right. Actually, I'm going to run into trouble with this slightly worse error message because in a couple of weeks we're going to want to run the libpython, like the standard library test suite, and the standard library test suite is probably contains tests for all the cases, like having a tuple here or a subscript or whatever, and those tests will then fail because my error message is slightly worse. And yeah, I might probably have to go and fix it then, but I'm going to leave it for now. Actually, that's a bit of a, I mean, different error messages is sort of one of the cases where PyPy and CPython diverge. It's sort of agreed upon that error messages cannot really be relied on. So sometimes we have slightly better error messages, sometimes we have slightly worse error messages. And it's always a little bit of an annoyance that the CPython test suite actually tests for the error messages, which makes sense from CPython's point of view, of course. But for us, it's sometimes quite a lot of hassle to sort of either we fix the test, which means we need patches for our copy of the standard library, or we have to go around and really implement all the error messages of CPython in exactly the same way, which we often want to do if the CPython error messages are good, but sometimes they are bad, and yeah, and then we're annoyed. Right. So and here we're worse, and I'm probably going to have to fix it in a couple of weeks. Right. We can commit that. Right. Okay. I think we're getting there slowly, and now there's one case that I haven't implemented yet, which is quite annoying, and I'm not really sure I want to do it completely, but I want to start into it a little bit. Actually, so there are two things I still want to do for the Walrus operator here on Twitch. One of them is I want to look a little bit into the issue that I'm going to tell you about in a moment, and the other thing I want to do and show you how that works is I want to try to translate the new PyPy interpreter that we just worked on to C, to give you a little bit of an impression of how the translation process works, because most people probably have never seen that, and I'm not sure whether it's just going to work on the first try. Then that would be boring. It would be more interesting if I actually made a typing mistake, and it would be more interesting if we got a spectacular failure of translating the code to C. And given that translating to C always takes quite a long time, it takes about an hour, I'm going to start it now and then talk about the other issue. And then maybe while we fix the other issue, we can either see the crash of the translation, or we can see that it gotten far along enough that it's likely not going to break. Right. So this is where you start the translation in the goal directory, and there's a script called rpython bin rpython that you use to start to compile the interpreter to C, and you can just start that. Annoying. You can just start that like this. If you have a PyPy installed, or if not, you need to the path to PyPy or CPython also works. Oops. Like so. We always translate with PyPy nowadays because the translation process is very slow, and PyPy actually speeds it up nicely. So we always do that. And actually, I'm going to stop it now. We're actually happy to do that with a slightly simpler, slightly faster option, which is to not build in the JIT. We can produce an executable that doesn't include a JIT, and doing that is about twice as fast as adding in the JIT, because automatically generating the JIT takes quite a lot of time. So building it in, takes longer. And also, I want to give the output a file name, PyPy C3 walrus, no JIT, and I want to static. Right. Oh, what's it called? Static is not so important. Let's start. Okay, now we're starting the translation. The translation is complicated. It will take all this code that we wrote to build the interpreter, and it will perform type inference, and it will take all the code and analyze all the types, and then it does some kind of lowering operation to take all the functions and produce a somewhat lower level version of all the functions. And then it does a number of classical compiler optimizations like inlining and constant folding and stuff like that. Then it builds in a garbage collector because we always need that, and then it produces C code and then calls the C compiler to translate that into a binary that behaves pretty much like CPython, particularly since I didn't build in a JIT. So without a JIT, it's really a lot like CPython, and you get a binary that you can just run. Right, okay. So I didn't want static, I wanted no shared. So what I'm doing with this option is that it doesn't produce a shared library and then a tiny executable. It just produces a statically linked binary. And the reason why I'm doing that is because I have this habit of having lots of binaries around from various experiments. And if they're statically linked, then you can really just take the binary and do stuff with it, and don't need to carefully also copy the shared library around. Okay, now it started the process, and the process is starting. Yeah, it's starting all kinds of things. But the first step that really happens is it will look for all the modules that we want to build in, like AST module and all kinds of modules, and they're just going to be compiled into the binary, and then it starts the type inference process. And I think it's going to do there's some kind of implicit order of the type inference process, and the compiler is relatively early in the process because it basically starts from the main method of the interpreter, and the main method will compile stuff relatively early. So we should find the type errors in the compiler quite soon in this process, I hope. Right, but now we wait. So there's an in-joke that says that PyPy gives you time for lots of sword fights because indeed the translation process is so slow. And so while we wait for that, we can dive into the other issue that I promised you we would still get to. And that issue is the following. I'm going to demonstrate it on CPython first again. Why is this so broken? Right. So there's another interaction between list comprehensions and named expression that I wasn't aware of, and that's the following. You cannot assign to you cannot use a named expression to assign the name that is defined by the list comprehension or other comprehension. So assignment expression cannot rebind the comprehension iteration variable x, and that's something that we're not really catching yet. Indeed, if we write a test for that, it will probably just work. What we would like is an error test. And it will just pass, I think. Right. Let's try it. Now we're waiting even more efficiently. We're waiting in parallel on the test and on the translation process to get somewhere. Right. And I'm actually not sure I want to implement this completely, but let's start at it a little bit. That's also something I learned only by reading some more of the C code that Batuhan pointed me to last week. Was it last week? Last year, a couple of days ago. Right, and it's basically this code. This is the code that corresponds to the symtable .py file that we have been editing, and what it does is, if we are in if we look at the list comprehension scope and we look up the name of the named expression target in that scope, and we find that it has the flag that it's the iteration variable of the comprehension, then we will produce this error, named expression conflict, which says assignment expression cannot rebind comprehension iteration variable name. Right. And that's kind of the thing that we're not doing. And the annoying thing is that in order to implement that, we also need to implement this flag. And that is a bit complicated. Right. So we add a flag to the flags of the variable that is the target of an assignment in a list comprehension. So let's try to see whether it crashes in a bizarre way that I'm not going to debug. But it's definitely, something's broken, and it's broken in that line here. So we should try to figure out. We should try to figure out how to produce the error that we're not getting now. Okay, so we're going back to the symtable. Maybe we can look, no, first we need to look a little bit more at how CPython does it. It has a visit comprehension visitor method and function, and what it does is it says, before visiting the target expression, it says comp iter target equal to 1, then it visits the target, and then comp iter target is 0 again. And then there's another place for that, okay. And that's initialized to 0. And then in the code that adds a new flag, it says, okay, if it's the comp iter target, we add another flag here. There's some more code that says, okay, that produces some kind of other error, And I think that case I'm definitely going to ignore. It's a case that says comprehension in a loop cannot rebind assignment expression. Ah, it's the same one. Ah, okay. No, it's not the same one. Ah, okay. There are two cases. There's also the other case. When does it happen? The other case happens, I'm not sure. Maybe something like that. I suppose I could just look at the tests. No, that's allowed. Okay, there's a more complicated case that that produces an error, and I'm definitely going to ignore that. But the other one, this one, I think we should get to, because it's not very complicated. A little bit complicated, but not terribly complicated. So we need a couple of components. At first, we need to figure out when we are handling the target of a comprehension. Right. So here we have a visit comprehension, and we do a walkabout which calls the visitor on the target. And then around that, we need to say somewhere we need to say new scope dot, what is it called here? Oops. We need to set an instance variable comp iter target to true. Let's follow CPython quite closely. Comp iter target equal true, and then afterwards we say comp iter target equal false. Right, and in the function scope we need to set in the init function we need to say self dot comp iter target equal false. Right, that's good. And cool. So that's the first step. And now we need to do something with that flag somewhere. And what CPython does is it has a flag def comp iter, and it will add that flag in the node symbol function to the flags of that name. So node symbol. Right. Yeah, somewhere here. Somewhere here. So, right, that's a scope. So here we can say if self dot comp iter target, then new role what does CPython call it? Let's follow that. Comp iter. Like this. And this flag doesn't exist yet, so we need to add it at the top. Here, some comp iter equal 2 shifted by 5. Right. So now we're writing that. Actually, I just realized that we need to, the place where we set comp iter target, we did that only in the constructor of the subclass function scope, and we need to really do it in the base class, because the node symbol method that we're just changed that wants to read that flag is actually on the base class. So let's go to the base class init and add it here. Right there are various other flags here as well. Right. Okay, so if we're noting a symbol and we know that the symbol is part of the target of a comprehension, then we're adding this flag. And now, so now we have the flag in the flags of a symbol. Now we need to use it. We're not using it, we're only setting it. And we need to use it in the code that we have been writing here. Okay, let's see how CPython does it. Right. If we are in a comprehension, we're reading the symbol, and if the flag of the symbol has this bit set, then we produce an error. So if parent dot let's see, parent dot lookup role name and simp comp. If then we raise a syntax error, and let's look at what's the syntax error again that CPython gives. X equal X for X in 1. Something name. Okay, and now we need a line number and a column number, column offset again. The line number is going to be node.line now and node.call offset, I think. Right. Yeah, that's what we do down here. That looks good. And I think this doesn't work yet. I think it doesn't work for a complicated reason. I'm starting it, maybe somebody else sees it too. It doesn't work because we start up one stack level. We don't start at the current scope when we walk the scopes. Here it says -1, so we start at the next to last scope, but I think we really need to start at the current scope, because otherwise we wouldn't find any problem with the comprehension that we're currently in, only with the containing ones. And how does it do that? It starts with the current one. It starts at size -1, not size -2. And so we are going to do that too, and then we will do a continue here like CPython does. Right. Okay. Okay, this is the run that should still crash because I didn't fix the oh, interesting. Right. So ist comprehension is also not defined in the correct base class. We only added it to function scope, and we need to add it to the base class scope again, like we did with the compiler target. Actually, I'm very unhappy with this flag, and maybe I'm going to change the use of this flag in a couple of minutes. This has a chance of working. By the way, as a complete aside, there's also, there's also a little bit of interesting stuff happening in the compiler in general, and this is kind of a line where one can spot the problem. All the code of the interpreter of PyPy is Python 2 based, and that means that this line here is really not a Unicode string, it's a byte string, because it's Python 2. But Python 3 supports names that are Unicode. So how does it work? And the trick is that all the names in the compiler and all the code fragments in the compiler are consistently encoded into UTF-8. And then whenever we actually display such a syntax error, we decode it into a Unicode string using UTF-8 again, and then stuff happens in the right way. But that's basically the trick. All the strings that we operate on in the parser in the compiler are really UTF-8 encoded byte strings, and then only when we actually talk to the user will we convert them into Unicode strings by decoding them. Cool. Our test passed. Hi, Tobias. Okay, that looks good. There's some not beautiful white space. Okay. What's it called? Produce a syntax error when we try to assign the iteration variable of a list comprehension using a named expression. Okay, good. So now that we did this, we can go back and look at what the translation is doing, and we can go to that tab, and it still happily works. So the type inference hasn't found a problem so far. Yeah. The type inference will produce beautiful ASCII fractals to make them slightly less boring to look at. But we don't see a lot of angry red error messages, so that means that the code that we've been writing doesn't really have a type error. Or at least we didn't find one yet. It's still possible for it to crash in the next couple of minutes. It's looking quite good. That's good. We will just let that continue running. I mean, it will not pick up the changes that we're doing while we wait for it to finish, but that's fine. It's already very good information to know that the version we had like 3-4 minutes ago is type correct. Right. Okay. I said that I'm unhappy with this is comprehension flag, and I wanna get rid of that. The way to get rid of it is to encode it in the class. So basically, I want there to be a subclass of scope that says comprehension scope, and then we don't need the flag at all. We can just check whether it's an instance of that scope or not. So let's kill that. Here we set it to true. That means here we're going to say comprehension scope. And that means is instance scope comprehension scope. Here as well. And now we need a new variant of function scope. Where's the function scope? Here. And that is going to be called comprehension scope. It doesn't have any code in it. I'm not sure what you're... this one. Yes, thanks Tobias. Well spotted. Exactly. Thank you. Right. So that's a comprehension scope. Yeah, I got it. Thank you. There's a slight lag between the chat and the video. So right. Okay. Cool. I like this. That should still work. Let's run the tests. The other thing that I'm now wondering is whether we can do the weirdness around what was it? What was the other flag that we added? Comp iter target. Whether we can do something to have that only in the comprehension scope. But that might be pushing it. Then we would have to override node symbol in the subclass, and yeah, maybe it works. Let's see whether those tests pass. Yeah, it's a bit annoying. We're doing something in the middle of the code here. It could be done, and if we wanted to be nice and object oriented, we could do it. But let's remain pragmatic and leave it in the base class. Right. Get rid of the is comprehension flag and use a subclass instead. Cool. This still works. So basically, we're out of tasks. We're fairly. I mean, I'm fairly convinced that I got most of the major cases now. We're catching quite a few of the errors, if not really all of them yet. But in many ways, we're done with Walrus operators. Batuhan, that sounds like a good plan. Do you have an example that should fail handy? It's definitely a good thing still to do. So suppose I can really look at the test. Lib test named. What's the error message? This one. Comprehension inner loop. Right. Yes. Yeah, let's deal that. Okay. Oops. Right. Tobias, please say hi back. Okay, we can write a test for that. Okay, so the theory is that this is easy according to isIdentical. So we, at the place where we set the flag, we check whether the old value already has a global or a non-local set. And if that's the case, the reason for that is that a named expression in the outer loop, in the if branch, for example, made sure that that flag was set, and then we know that we have a conflict with that, with the inner loop. Right. So here, do we read the old flag somewhere yet? We don't, I think. I'm a bit confused. What does this code do? Where do we write to val? Right. We set val to this check that we've been doing. Right, okay. The val is the current flag, and if there are no current flags, it's the new flags. So basically we say val equal role. No, wait, how precisely do they do it? Right. So new role has the old role or together in this line. So new role is already the variable that we can use. Here. So here we can basically say if new role and how did it work? Global or non-local. So some global or some non-local. Then we have a problem, correct? Right. Raise syntax error, and the error is the one that we have on the terminal. Name, no identifier, and oops. That works. Bye, Tobias. Okay, maybe that works. That was stressful. At least it looks very close to what CPython is doing. Okay, waiting in parallel again. The tests are running, and the type inference is still happily producing colored characters. Yeah, and some parts of PyPy development are actually quite boring to stream because sometimes it really involves a lot of waiting. You start a translation or the type references process, and then you wait for it to crash, and then you fix a little small thing, and then you wait for it some more. Unfortunately, we never really managed to make it incremental. No, it doesn't work. This weird error is if we have an error test that doesn't produce an error. So this did not work. Why not? Okay, I'm a bit clueless. I think I see. Because for it to work, comprehensions are really... Wait, let me try to figure out how... If we don't have an error, how nested comprehensions are actually compiled. Okay, right. Oops. Trying to do too many things at once. Right, it's not so this kind of comprehension is really only one comprehension. It's not really a nested comprehension, it's a comprehension with a nested loop, but it's still only one scope. So maybe we're not setting this flag correctly in all the cases. So this flag here, maybe there's another place. I mean, here it says outer target. Maybe that's just for the outermost loop, and we need to figure out whether there's another place where we need to set it. I don't quite understand how the AST of comprehension works. Let's look for more targets. Seems not. Where does CPython set that? Compiter target. So CPython has two places where it's set, so I suspect we're missing the second case. Where is symtable visit comprehension called? It's not. So do we have a visit comprehension method here? There's a generic, so I suspect it's in here, the generic AST visitor.visit comprehension. So he's saying 460 and 61. I'm not really sure the line numbers still match on my branch, but I think I was in the correct place before here. Yes. So we're calling this default implementation here, I think. And that's why we didn't find the target dot walkabout, because it's in another file. So I'm going to stop calling it and copy the implementation of that method in here. Come on. Alright, then I kill this, and then around the around the target here, I will set the flag. Do we even have a visited implementation? No. Okay. That looks plausible. Okay, you can't tell that from the colors, but it reached the second stage, the lowering stage. That means the type inference didn't find errors. So the code that we wrote to implement the walrus operator is type correct, or at least it didn't crash in the first stage, and most of the type errors happen in the first stage, so we're probably good. That's great. That means if we waited long enough, we would eventually get a binary in C that has the walrus operator. We might not be patient enough for that though. Oops. Damn it. I went to the type inference to waste some time while we waited for the tests to run, but I didn't hit enter, so we were not waiting efficiently enough. Okay. By the way, if there's anything you would be interested in me talking about, then please write some questions into the chat, because as you're noticing, I have these occasional minutes during the development time where I'm waiting for stuff, and I'm happy to talk about things that interest you. Or more generally, write me and I can cover things that people are interested in. Yeah, of course, I am not careful enough at all. New scope should be self.scope. Wait, I need to prevent this from happening. Sorry. Right. Any minute now. Cool, it works. Excellent. Yeah, thanks Batuan for encouraging me to fix it, because it really wasn't that hard. Okay. Cool. So I think we're in a pretty good state. We can look at some more of the tests, but I suspect that we're actually doing fairly well. There are a lot more error cases that that we're not explicitly testing for yet. But so basically my testing philosophy for a feature like that is to do a reasonable job to write tests, but then all of the really heavy corner cases testing we will get once we manage to run the CPython test suite for the feature, which will be not in a couple of weeks probably, because right now we can't run the CPython standard library of 3.8 because we're still missing a couple of the features that are necessary to bring up a lot of the standard library modules, like positional only arguments and the walrus operator and a few other small ones. So right now we can't run the test suite yet, but very soon we hope that we will be able to, and then we will run all these tests here and get told off if we're not doing the error cases correctly. Right. So yeah, so we're kind of we're done with this. Batuhan, is there an obvious case that I'm missing now, or am I doing fairly well? Otherwise, we need to come up with something. Do you know of a test for that? Otherwise, we need to find something else to do while we wait for type inference to go further. We have that, I think. Okay. Those are called by the grammar. Those we don't do. This one we did earlier. Which one? Ah, you mean the fact that we're producing the wrong names? This one, I suspect. But that error isn't produced by the symbol table. It's produced by some other part of the parser. Let me grab for it. Compiler expert. Right. Sorry, I'm not. Don't we do that? Assignment expression cannot be used in a comprehension iterable expression. Assignment expression cannot be used. Of course. There's another place where we can use an assignment expression together with list comprehensions, which is on the iterator side of things. La la la. Right. Okay, let's do it. This is fairly typical in my experience, by the way. The fun part of implementing stuff doesn't take that long, and then you spend a lot of time on doing kind of annoying and lengthy error cases or corner cases. Right. I suspect we're not catching that yet. But it doesn't look incredibly hard. Right. Okay. We need to be. There are some things that we need to fix here. When we start handling a named expression, we can check whether the current scope is an iterator expression, right? We have an iter target and the iterator expression. And if that's the case, then that means we need another counter. And if that's the case, then right, then we just forbid the named expression from occurring. Okay, there are probably 17 variations of this, but let's fix at least the simplest version of the problem. Okay, let's see. So the code goes here. No, wait, I'm in the wrong file. The code goes here. Right. What does CPython call it? Comp iter exper. And it's not a flag, it's a counter. And then we can just raise, because the named expression is just completely forbidden in there. So we just say raise syntax error, this. Right. And now the main work is going to be to set this counter, to increment and decrement this counter correctly. So we need to initialize it to 0 in the base class. Wait, competitor exper. And now we need to increment it somewhere. Visit comprehension. Here around this, I think. Self.scope.comp iter. This. And there is another case, or for the outermost one, as we discovered earlier. And the outermost one is looked up in the outer scope. Oh no, wait. So it's correct to say self.scope here and not new scope. But then there seem to be more complicated cases in here. This one we have, this one we have, that's the initialization, and I do not understand that one. In push scope, we need to inherit the flag from somewhere. I kind of would like a test for that. Push scope. add child. Right. Right. And I think we can do it in the add child method. Of course, I forgot the name of the flag again. Comp iter expr. What's the comment in CPython? Disallow all assignment expression in the outermost iterator expression. Let me actually copy that comment. It's a good comment. Okay, plausible. Maybe that was enough. Type inference is happily chugging along. Yeah, I think the other thing that we can still do that we can still usefully do while we wait on stuff is the fact that we're producing a slightly worse error message in the one case. So in this very first error case, CPython gives a better error message, and I think I want to steal that. And for that, we need to sort of come up with a name for the left-hand side of the that we get here, but we can find out how CPython does that, I think. It's probably in here. Where's ast.c? Not here. I don't know the CPython directory layout enough. Python, obviously. Named expr. Yes, it's a good question. Where does the validation? Where it produces the error, I'm not completely sure. What's the error message again? Cannot use named assignment. Maybe I have a slightly different. Yeah, this is 3.8.0 and the checkout is probably 3.8 point whatever is out, so the error message is slightly different. And it's in AST for named expression, and it says expr name, and there's a function called get expr name, and that switches on the type of the AST, and then has various helpful explanations what we have. Does it? Right. Okay, so we need an equivalent for that, and I don't think we have that in AST Builder. No. What is the? I'm wondering who else calls this function? Set context. So if you say none equal phi, right? That's also that also uses get, the same get function to produce this error message. How does PyPy handle that? Right. It's a forbidden name. What is something else that you cannot assign to? Maybe that's in the validator. So we need to figure out where PyPy produces this error message. AST helpers. Okay. I have never heard of this file. Right. There's an underscore description. Okay, that underscore description on the various classes can probably be used in what we're trying to do. Right. Cool. Does every AST node have a description or only an expression? Only the expressions. So, by the way, as an aside, we do some fairly scary stuff here. AST nodes have weird meta classes that allow you to add bits to the class from various files. So if you have a class named __ extend of subscript, then the class body, we don't actually make a new class extend here. We add all these functions in here into the class that we're subclassing from. So that's a little bit weird. It allows us to sort of distribute various helper functions into different files and sort of slice the view on classes somewhat differently. So that means we group all the descriptions into this file, and we don't have to put them all into the anyway, in any case, automatically generated and an already huge file called ast.py. But then we can still, when we have an AST node, we can still access those attributes from anywhere. Right. So in AST Builder, what we will do is do we use the description here somewhere? No, it seems only AST helper is using that. So handle named expr. Right, here we will do something a little bit more clever. Instead of just saying that is not a name, we will produce a better error message. Okay, let's go back to what CPython does. Cannot use named assignment with none. And I think I think nowadays the newer 3.8 version doesn't call that named assignment anymore. It calls it what? This is the get expression name. Right. So this is the error message we want to copy. We're going to put it here. We've been bad citizens anyway here because we didn't add a line number and a column offset. So something here, and then expr node or I suppose we can use the target expr dot line node target expr dot call offset. Right. Okay, and here we can use the description somehow. Okay, and so here that's actually I mean, what we want to write is we want to write target expr dot description. But we cannot do that because and this is the first place where we need to think a little bit about the types that the type inference engine will produce for this function. So I'm not completely sure that the type inference engine can find out that the result type of handle expr is always a subclass of ast.expr, right? There's a class expr here, which is the base class for all kinds of expressions. This one. And handle expr always produces a subclass of that and not a subclass of the more general base class ast, right? So and a subclass of expr is stuff like a bool op or a named expression or a bin op or whatever. But we can't be completely sure that the type inference engine will find out that the type of target expr here is expr and not ast. And if we access the underscore description, that's a little bit risky because if the type inference engine assumes the target expr is an ast here, which is not quite precise because in practice it cannot be anything further up than expr, but I'm not completely sure that it can find out that it's always an expr, and we can help it and say I am sure that target expr is always an expr here, and then the underscore description works because all subclasses of expr have an underscore description attribute. And that's just being a little bit defensive because it's possible that the right thing would have happened anyway. Right. Right. And I kind of want to write a more careful test that really inspects the error message to check that we're doing something, that we're doing the correct thing here. So I'm actually going to add a new test method here. Def test walrus operator error message. I mean, particularly for this case. So now we say I'm not sure. Phrases. Right. So seems there aren't a lot of cases here that check for error test kind of does the right thing, but it doesn't give us access to the simple test, none, none. And that will raise a syntax error, and then we can say assert info dot value, that's the instance, and what's the field name, message equal, and that's not the thing I want to test. What I want to test is something like and that should give me cannot use assignment expression with tuple. Bye, Batuan. Okay, that looks great. I'm going to look at it probably not tomorrow, but definitely within the next couple of days. Thanks a lot for that work. Right. Okay. Let's see. Oh no, wait. I can run only the second. I suppose I can run them all. Okay, so here, while we wait for the tests, here we're past the next phase. So the first phase of translation is type inference, which basically finds out the type of every local variable in all the reachable functions of the program, and all the instance fields and stuff like that. And then there comes a second phase, which is a lowering phase, which takes all the functions in the program and lowers them to contain only operations that kind of are much closer to C. And the next phase, which we're currently running, is basically an optimization phase, which does all kinds of classical compiler optimizations like inlining. And currently we're still busy with inlining. Right. Ha. Okay, I'm going to accept that. Right. Actually, I suppose we could have another one here and say maybe a lambda. Right. Some more waiting. I'm going to wrap up the stream in another 15 minutes or so, I think. We're at a fairly good ending point. We implemented a lot of the corner cases of the Walrus operator, the named assignments, the named expressions, I mean. And so I don't think it makes sense to start another topic now. Unless anybody has some questions, then please just write them into the chat. Okay, tests pass, that's cool. Let's look at the diff. Right. Yeah, we're kind of mixing two things together here. It's a little bit unnice. So yeah, we can separate these two things. On the one hand, we improved the error message here by adding the type of thing that we're trying to assign to, and on the other hand, we still did the other corner case of comprehensions. So I'm going to split that up into two commits, and I can do that with HGRecord, but I can also do it slightly manually by deleting that case and then committing compiler and as compiler symtable. Produce an error in another corner case of named expressions, forbid them in the iterator expression of comprehensions. And then we re-add the test, and right. Okay, that's good. Okay, so we can push those changes, quite a few of them. Let's see. Is anything happening on RC? Not really. Right. Okay. I don't really want to open a merge request now, but we can see that basically pushing stuff triggered CI on our server, which doesn't really run all the tests, but it will run the type inference to figure out whether the new code that we pushed has some typing problems. Right. And that's basically kind of equivalent to the code that we've running in the second terminal tab. In a couple of seconds, it will start showing the same fractal, and that will give us an error if there are any typing problems that we haven't that we have added, basically. Right. And the version that we're running here has continued. It has inlined 99,000 call sites, and then it starts a fairly important second optimization, which is called malloc removal, and that's basically the main reason why we don't leave all the optimization to the C compiler. The Python code produces a lot of allocations all the time, like we make tuples and we return tuples, and we have iterators and for loops, and all of these allocate all the stuff, all kinds of stuff all the time. And a lot of these allocations have limited and predictable lifetimes. So we produce a sort of small kind of escape analysis on the RPython code, and we will remove the allocations that are sort of very predictable and happen only and where the allocated objects don't really survive outside of the current function, and then we replace the allocated object with all of its fields as local variables, and that makes the code a lot more efficient. And that's also something that the C compiler cannot do for us at all. So we cannot rely on only letting the C compiler optimize the produced C code that we make from our Python code. So we did that, and now we have something called stack check insertion, which makes sure that we don't run out of C stack by adding checks into the call graph at places where we can recurse indefinitely. And then the next step after that, I'm not going to wait for that to finish on the stream, but the next step after that is producing the garbage collector and sort of weaving in the garbage collector. We're not using reference counting like CPython, where we have a generational mark and sweep, which also has an incremental major collection. So that gets built into the final executable, and then only as the last step do we produce C code and compile that. Yeah, but I'm going to wrap up the stream now. Thanks a lot for being around, and I will probably continue maybe next week with another 3.8 feature. Thanks a lot, and have a nice rest of the weekend. Bye. Okay, so a tiny bit of bonus content for the YouTube version. The compilation has now finished after just 100 minutes. I mean, it's competing on my CPUs with OBS and video encoding, so it's a little bit faster usually. But anyway, it's now done, and now we have a Python that looks like a completely regular Python. It's basically a 3.7, but it supports the Walrus operator that we implemented on the last stream and this stream. So we can do useful things like this. Okay, that's it.